I believe everyone can hear me. Welcome once again to our A1 Tutor Live class. And today we're going to be considering the subject mathematics, and it's going to be the continuation of our previous topic, which was logarithm, indices, logarithm, and surds. Indices, logarithm, and surds. In the previous class, we've done justice to indices. So today, we are going to ensure that we cover up for logarithm and surd. Logarithm and surd. Okay, if you can hear me, please kindly signify in the chat. All right, Sabi Emmanuel, thanks for your response. Okay, so let's proceed. Today we are going to consider logarithm first. Then after that, we'll move to surd. Logarithm. I believe you can see the screen as well, right? If you can see the screen, kindly signify also so we can proceed. All right, thanks for your response. So we are going to first treat the law of logarithms. Then after, we're going to take some applications that has to do with UTME question. Some applications that has to do with UTME question. Okay. Let's proceed. So the first law of logarithm is the addition law. The first law is what? The addition law. The addition law, which states that the log of b, the log of x base b plus log of y base b is equals to the log of xy base b. The log of xy base b. Okay, the log of x base b plus the log of y base b is equals to the log of xy base b. All right, so that's the first law of logarithm. And let's take an example on this. If I'm given this expression, log of 6 base 6 plus log of 5 base 6 is the same thing as log of 6 times 5 base what? Base 6, which is equals to log of 30 base 6, which is equals to log of 30 base 6. All right? So that equals to log of 30 base 6. Okay? So if we are given this also, we are given e.g., we are given the log of 30 base 6. We can also express it as log of 6 base 6 plus log of 5 base 6. So it is the law states that we change multiplication to addition, and addition changes back also to multiplication. So that's the first law of logarithm. If that's clear to us, please kindly signify. We'll move on to the second law. Okay, so we are going to move on to the second law, which is the law of division. All right, so permit me to clean the board. The second law, the law of division, or we call it law of subtraction. Subtraction. So we have the log of x base b minus log of y base b is equals to the log of x over y base what? Base b. X over y base b. Or you can write it this way, log of x base b divided by log of y base b. So minus we change to what? Division. Minus we change to what? Division. I believe that also is clear to us. So we'll take the next law of logarithm. That's the law of exponents when we have a power. If I'm given the log of x raised to power n base b, the log of x raised to power n base b, it is also the same thing as this exponent comes to the back here, and we have it as n log x base b. N log x base b. Is that clear to us? Okay, thanks for your response. So we'll move on with the law. What about the next one we want to consider is when we have log of the same base. Okay, if I have log a base a, my answer will be 1. E.g., if I have log 10 base 10, it is 1. Log 5 base 5 is also what? 1. Okay, log 10 base 10 will give me 1, and also log 5 base 5 will also give me 1. I believe that is clear, right? So these are the laws we're going to be working with today in our applications for logarithm. So if the laws we've discussed so far is clear to us, please kindly signify. We want to pick up some application because we are still going to consider sorts today. So we need to be time conscious. All right. So permit me to rub the board. Okay. All right. So let's proceed with applications now. We'll pick the first application. App 1 under logarithm. App 1 evaluates evaluates 2 log 9 base 3 multiplied by log 81 raised to power minus 1. Okay, base 3 also. All is divided by log 625 base 5. This is a UTME question 2019. UTME question 2019. Okay, so let's solve this together. It's very simple. We just need to apply those laws we've learned in the previous explanation I've just given to us the other time. We apply those laws to all this expression we have here. So let's go. We have 2 log 9 base 3 multiplied by log 81 raised to power minus 1 base 3 is divided by log 625 base 5. Okay, so how do we work in log? You need to be very smart when you are solving log question. Okay, check the base here. The base is what? 3. So I need to express this 9 in times of what? 3. So 9 can also be written as 3 square. Okay? 9 can be written as what? 3 square. So I would say this is 2 log 3 square base 3 multiply by this 81 also can be expressed in terms of base 3. Can be expressed in terms of what? Base 3. So 81 is also 3 raised to power 4. 3 raised to power 4. So that will give me log of 3 raised to power 4 in brackets minus 1 base 3. Okay? Over the base here is 5. So that means I have to express 625 in terms of what? 5. 625 in terms of 5. So that will give me 5 raised to power 4 is the same thing as 625. So at the denominator, I will have log 5 raised to power 4 base 5. Base 5. Okay? So let's proceed. All right, so let's proceed. So for this expression now, we need to apply the law of what? Logarithm. One of the law was saying that if I have log x raised to power n base b, I'm going to take this power to the back here. Okay, so that is what I have to do for these expressions. These two will go to the back of log. Okay, and this also minus 4, because if I multiply 4 times minus 1, I'm going to get minus 4. That also goes to the back here. And this 4 also goes to the back here. So what I'm going to be having, we'll be having this expression next, 2 times 2 log 3 base 3 multiplied by minus 4 log 3 base 3 over the 4 also goes to the back here. We have 4 log 5 base 5. Okay? 4 log 5 base 5. Another law of logarithm states that log a base a is equals to 1, which implies that log 3 base 3 also will be equals to 1. Log 3 base 3 also will be equals to 1. Log 5 base 5 will also be equals to 1. So that will give us 2 times 2 log 3 base 3 now is what? 1 times minus 4 log 3 base 3 is also 1 over 4 in brackets log 5 base 5 log 5 base 5 is also equals to 1. So we have 2 times 2 is 4. 2 times 2 is 4 multiplied by minus 4, all right, over what? 4 over 4. Okay, so let's proceed with that. What we're going to have here is minus 16 over 4. Minus 16 over 4. And when you divide that, you're going to have minus 4. Minus 4. So the response for this evaluation is going to be what? Minus 4. I believe that is clear to everyone. Response, if the explanation is clear, okay. Thank you, Emmanuel. Temilolua, thank you for your response. So we can move on to the second application. Okay, let's move on to the second application. All right, we are going to take another UTME question. Up to we have evaluate log log 8 base 2 minus log 1/9 base 3. Okay, so this is the next question, UTME question 2010. UTME question 2010. So let's go on to solve this also together. Evaluate this minus this. Okay, so we take the first expression, log 8 base 2 minus log 1/9 base 3. So the hints or the trick there is that always check your base. Okay, when you check your base, you'll be able to know what to do. So the base here is 2. The base is what? 2. So I need to express 8 in terms of what? 2. So 8 should give me 2 raised to power 3 because 2 times 2 times 2 will give me 8. Okay, so that means log 8 can also be written as log 2 raised to power 3 base 2. All right, minus this expression. Now you can see that indices also is needed in logarithm. Indices is needed. So you should understand what 1/9 means with the knowledge of indices. Okay, with the knowledge of indices. 1/9 is the same thing as 9 raised to power minus 1. 1/9 is the same as 9 raised to power minus 1. So that is log of 9 raised to power minus 1 base what? Base 3. Base 3. Okay, so now let's simplify this 9 in terms of the base. The base here is what? 3. So that implies that 9 also can be expressed as 3 raised to power 2. So we have log 2 raised to power 3 base 2 minus log 3 raised to power 2 in bracket minus 1 base 3. The law of logarithm that states that log x raised to power n base 2, base b, this n comes to the back of the logarithm. The same thing applicable here. 3 comes to the back here, and this minus 2 also comes to the back here. Okay, so we're going to have 3 log 2 base 2 minus in bracket minus 2 log 3 base 3. Okay, so now we need to apply another law that says log a base a is 1, log 2 base 2 also will be 1, and log 3 base 3 will also be 1. So we have 3 in brackets 1 minus 2. Log 3 base 3 is also 1. So we are left with 3 minus times minus is plus. 2 times 1 is what? 2. So the answer will be 5. The answer will be 5. So if that's up to is clear to us, please, if it's clear to you, kindly signify. So we move on to the next. All right. Okay, thanks for your response. So I've reserved some questions for us to use as evaluation. So take note that you also are going to solve some question for me at the evaluation period. Okay. So Very quickly, we are going to brush through the, the laws of sort. The laws of what? Sort. We'll be taking more questions when you are doing the evaluation under logarithm. Now let's consider the law of what? Sort. The law of sort. Okay, so the first law of sort is given as the square root of A plus the square root of B is not equals to the square root of A plus B. For example, if I'm given the root of 2 plus the root of 3, it is not equals to the root of 2 plus 3. So this is not allowed. If I'm going to add it together, they must have the same value. Like root 2 plus root 2 is something we can add together, but we cannot add this together, okay? We cannot add these together. B, if it is the root of A minus the root of B, is not also equals to the root of A minus B, is not equals to the root of A minus B, okay? If I'm given the root of 7 minus the root of 8, it is not equals to the root of 7 minus 8 because they have different values inside the what? The roots. So we cannot take the subtraction of both. Okay? So that is the second law of sort. The next one we are going to consider is the multiplicative part of it. If I have the root of A times the root of A, the answer will give me the root of A all square. Square cancels square roots. So the answer will be what? A, which implies that the root of A times the root of A will give us what? A. So if the root of 3 multiply the root of 3, the answer will be what? What are you going to have as the answer? In the chat box, what are you going to have as the response? Root 3 times root 3. Okay, 3. Correct. That's 3. The response will be 3. Thank you so much, Demilolua. 3. Okay. So that is another law. The next law we are going to consider is another law of multiplicative. If I have root A times root B, it is equals to the square root of A times B. The square root of A times B. E.g., if I have root 2 or root 3 times root 2 is also the same thing as root 3 times 2, which is what? Root 6. Which is what? Root 6. So these are some of the law of sort. Okay, we still have more. We are going on with the remaining one we have. But if the ones I've mentioned earlier, if it is clear to you, please kindly signify. So we'll take the next one. All right. Okay, I believe you can see my board now. Can you see my board? If you can see my board, please kindly signify. Temilolua, can you see the board? All right, okay, let's proceed now. So we stopped on this rule. We want to take the next rule of sort that we have, and that's going to be the rule of division. Let's have that one by this side. E roots A over B is also equals to root A over root B. Root A over B is also equals to root A over root B. Okay, that's another law of logarithm. The next one we are going to consider is the law of rationalization. F, if I'm having a 1 over root A and I want to rationalize this, that means I'm going to have 1 over root A multiplied by the denominator, which is root A over root A. And that will give us root A over root A times root A is what? A. So this is called rationalization of surd, rationalization, okay? Rationalization. So we have another rule, which is going to be the last one, and that is talking about the conjugates, the conjugates, okay? So I'm going to have that at this portion of my board. That will be G. If I have A plus root B, A plus root B, the conjugate for this expression, the conjugate for this expression is going to be that we are going to change the sign in between both of them, and you're going to have the conjugate to be A minus root B. So the conjugate of A plus root B is A minus root B. A minus root B. Okay, that's the conjugate of A plus root B. Is that taken? So we have touched all the laws of what? Surd, and we want to put them into practice by considering some question under them. Okay. So if the laws of surd is clear to you, please signify. Kindly signify. Okay. All right. So we can proceed to take some applications on that. So permit me to clean the board. We are still on surd. Okay. So very quick one. I want to ask this question. Under conjugate, what is the conjugate of A root A plus root B? What would be the conjugate? What would be the conjugate of this expression? What would be the conjugate of root A plus root B? Response in the chat box. I'm waiting. What would be the conjugate of root A plus root B? Waiting for your response. You can just type the response in the chat box. The conjugate of root A plus root B. Still waiting. The conjugate of root A plus root B. All right, let me help us out. It's going to be root A minus root B. The conjugate will be root A minus root B. I believe that is clear to us, right? So let's proceed to take an application under the rule of surd. Okay, so the last application we did was up 2. So this will be application 3 for today's class. Application 3. I want to consider this question. Simplify 3 root 5 multiplied by 4 root 6 over 2 root 5. Okay, not 2 root 5, but 2 root 3. 2 root 3 multiplied by 3 root 2. A UTME question. This is a UTME question 1999. Okay, we have to simplify this expression. UTME question 1999. So to simplify this, we need to first understand every part of the question. 3 root 5 multiplied by 4 root 6 over 2 root 3 multiplied by 3 root 2. First thing you need to observe is that this question comes with the operation multiplication, not division, not subtraction, not minus, but multiplication. Okay, so we are free to do some division, like we are free to cancel out some value if they can cancel each other, since all of the expression are joined together with multiplication sign. Okay, it's just like we are having AB over A. What we have in between A and B is multiplication, so A can cancel A. Okay, so for this, we can say that 3 here, we cancel this 3. Okay, 3 we cancel 3. 2 here, 1, and 2 here, 2. So we are left with root of 5 times 2 root 6 over root of 3 times root of 2. I believe that's clear to us. Okay, so root of 5 times 2 root of 6 over root of 3 times root of 2. Okay, we proceed. Because we have multiplication, that means we can still divide. We can still divide further if we have some value that are what? Divisible. Okay, so here the denominator can be multiplied together. The denominator can be multiplied together. Of course, here also we can multiply together. So if the coefficient here is 1, I can multiply this together. I will say we have 1 times 2. I considered this first. I consider this times this. So that is 1 times 2. Now I will consider the what? The root. Root 5 times root 6, close the brackets, over. I can also multiply this together. That is root 3 times root 2, close the brackets. So when you multiply 1 times 2, you have 2. When you multiply root 5 times root 6, you have what? Root 30 over root 3 times root 5. That will give us root 6, all right? So we can divide this. Root 30 over root 6. That is 2, okay? 2 multiplied by a big root, 30 inside it, then also 6 under it. You know, one of the laws says the root of A over B is the same thing as root A over root B. So that's what we applied here. Root 30 over root 6 is also the root of 30 over 6. The root of 30 over 6. So that will give us 2. When you divide 30 by 6, 30 by 6, your response will be what? Root 5. Root 5. So the answer will be 2 root 5. 2 root 5. Okay, I believe that is clear to us. Is application 3 clear to everyone? Okay, all right, so let's take the next one, the next application. That will be application 4. Permit me to clean the board. Still under Surd. App 4 now. You want to consider app 4. Okay, so we're going to take another UTME question. If, all right, 24, root of 24, if root of 24 plus root of 196 minus root of 600 is equals to y root 6, find the value of y, find the value of y. So this is UTME question 2000. UTME question 2000. So in this question, we have to find a missing value, and that value is what? Y. We're asked to find the value of what? Y. Okay. So what is the trick in this question? First, you have to check what is the least root that you have in all this expression. The least root you have is root 6. is what? Root 6. So that means if you are going to get the value of y, okay, what you are going to have beside it as a root must be what? Root 6. And what we are doing is that we want to equate this part to this part. So when we have when we have the balancing done by equating this part to the other part, we cannot compare the value of y at this place to the other side. Okay, so the least root here is 6. That means I have to express 24 as root 6. I have to express 196 also as root 6, and also express 600 as what? Root 6. Okay, so let's take it one after the other. Root 24 is also equals to the root of 4 times 6. All right, I believe that is clear to us. So if I split this, I'm going to have root 4 times root 6, and that will give me the square root of 4 is 2. And the square root of 6, we don't have a perfect square root for it, so we maintain it as what? Root 6. Okay, so we have simplified this root 24. Let's take the next one, root 196. Root 196 can also be expressed as 16 times 6. 16 times 6. 16 times 6. You will see that I'm always making use of 6 because of what I have in the question here, this. So I'm working towards getting root 6, root 6, root 6, so that at the end I can get the value of what? Y. So that's the trick behind it, okay? So let's proceed. If we also split this, we have root 16 times root 6. The square root of 16 is 4, but we don't have the square root, we don't have the perfect square root of what? 6. So that would be root 6 again, since the square root of root 6 will be something like decimal, and we don't need that. We are working on that sort, so we are allowed to make use of what? Square root. Okay, so we have simplified this also. The next one to simplify is root 600, and I want us to tell me what will be inside this. Okay, in the chat box, how do we simplify root 600? I'll be waiting. Root 600 will be what? Just tell me the two values I'm going to multiply together to get that 600, and ensuring that 6 is part of it. Hundred and 6. Awesome. Good response, Emmanuel. 100 times 6. Thank you, Temilolua. Great response, Emmanuel. Great response, Temilolua. Okay, so we said 100 times 6. Okay, so splitting this, we have root of 100 multiplied by root of 6. The square root of 100 is 10, multiplied by square root of 6, which is what? Root 6. So we have simplified this also. Now, let's bring them together, okay? Root 24 is 2 root 6 plus the square root of 196 is 4 root 6, 4 root 6, okay, minus 10 root 6, 10 root 6, which is equals to y root 6, okay? So since the roots are the same, we can go ahead to perform a basic operation, okay? It's just like they are saying 2a plus 4a minus 3a. Since they have the same variable, a, you can what? Go ahead to add and subtract. So root 6, root 6, root 6. So we can add and subtract. So we're going to have 2 plus 4 minus 10, close the bracket. Everything is what? Root 6. Root 6 is common to all of them. Root 6, root 6, root 6 equals to y root 6. Okay, so when I simplify this, I will have 6 minus 10, okay, close the bracket, root 6 equals to y root 6. Take away 10 from 6, that is minus 4 root 6 equals to y root 6. And of course, we have our response already. So all I need to do now is what we call comparison. I have root 6 here. I also have root 6 here. Okay? So what will now be what? Y. Who can tell us what Y will be? In the chat box, waiting for your response. What will be the value of Y? -4, great response, Sadu Emmanuel. So -4, thank you, Temilolua. That's a great response. So this -4, you compare it to the other side here, which is Y, which means Y equals to -4. Y equals to what? -4. So this is going to be the response of that UTME question. Okay, so we are going to have some questions to evaluate ourselves now, and I want our participation. I want your activeness and your participation. Okay, so let's clean the board and have some questions to treat together, both under logarithm, okay, under logarithm and set. We want to have some question. So the first question I'm going to give us is simplify this. That's under logarithm. Simplify this. Simplify log 8 over log 4. Both are in base 10, base 10. Over to you. Over to you. That question. Log 8 base 10 over log 4 base 10. I want you to simplify that for me. Wow. The answer is 2. Sadu Emmanuel said the answer is 2. Do you have any other response? I'm still giving the grace. Waiting. Waiting for your response. We've gotten a response. Sadu Emmanuel said, Emmanuel, give us the response 2. Okay, Temilolu also said the response is 2. All right, so let's do it together. That's a great response, of course. So if I have log 8 base 10, it's the same thing as 2 raised to power 3. Okay, 2 raised to power 3 base 10. Do you agree with me? Divided by this also, what I have here, this expression I have here can also be written as log 2 raised to power 2 base 10. 2 raised to power 2 base 10. Are you following? So using the law of logarithm, this guy comes to the back. We have 3 log 2 base 10 over this guy also comes to the back. We have also 2. We have 2 log 2 base 10. Are you with me? So if you check this, you see that log 2 base 10, log 2 base 10 is the same thing. So these cancel out. We are left with 3 over 2, which is 1 whole number, 1 over 2. So our response is going to be 1 whole number, 1 over 2. So Emmanuel and Temilolua, kudos to you for trying and giving us a response. But let's look at this way, that our response should be this value, which is 1 whole number, 1 over 2. Okay, I believe that is clear to us. Is that clear to us? Okay, all right, thank you. So let's take one question under surd. One question under surd. I want you to simplify this. 5 root 18 minus 3 root 72 plus 4 root 50. Simplify this in surd. That's UTME question 2006. Simplify this in surd form. I'll be waiting for you. Simplify this in surd form. Waiting for your response. I believe we are solving it. Okay, to make it more easier, let me just write it this way. Yeah, I said 5 root 18 minus 3 root 72 plus 4 root 50. So I'm waiting for a response. You have to find a root that will be common to all of them. So if this is 5 roots 2 times 9 minus 3 roots 2 times 36 plus 4 roots 2 times 25. So I've simplified it to this extent. So carry on from that space. I'm waiting. Waiting for your response. Waiting. You just need to ensure that you are using the rule of sort. Ensure you are using the law under sort, okay? So you're going to get the accurate answer if you are using the law under sort. I'm waiting for your response. If you go further, you're going to get the square root of 9. You're going to get the square root of 36. Square root of 9, you are going to have a value for it. Square root of 25, you are going to have a value for it. So that will take you to 5 times. The square root of 9 is 3. So you have root 2 left there, minus the square root of 36 is what? 6. So you have 3 times 6. Put this in brackets. Root 2 left, plus you have 4 times the square root of 25 is what? 5. And you have root 2. Okay, so I've solved to this extent again. I'm waiting for you to perfect the solution. I'm waiting. If you go ahead to multiply this, that will be 15 root 2 minus, multiply this, that's 18 root 2 plus, multiply this, that's 20 root 2. So with this, we should get the final answer. The final answer will be 15 minus 18 plus 20. Okay, I have a response here from Emmanuel. He said 17. Is this 17 alone, or you have something after 17? Emmanuel and Temilolua, is it 17 or 17 something? Let me know your final answer. Of course, this will give us 17. And this, we have root 2 beside it. So root 2, thank you so much, Temilolua. That's a great response. Emmanuel, that's a great response. 17 root 2. 17 root 2 is the correct answer. Okay, so I believe today we've learned the law of logarithm. We've also talked about the law of sort, and we're able to solve 4 applications under UTME question for the topic logarithm and sort. Okay, so for us to practice the more, I will urge us to visit the A1 Tutor app and do practices of question under this topic. Just have to go to the A1 Tutor app, check for the CBT session of it, and practice question, because practice make perfection. Okay, and if you also want a detailed video that will explain logarithm and sort to you, also indices, you can have that on the A1 Tutor app. Check the video lessons. You are going to have a detailed video on those topics. It is under SS1 as a class, You are going to find indices under SS1. You are going to find logarithm under SS1 and sort also under SS1. Also in SS2. So you can do well to watch those two classes. Watch the topic, indices, logarithm, and sort. Okay, stay online. We are going to have the next class in few minutes time. Ensure you are online to take the class and you will not be missing the class. It's always good to ensure that you are present for all classes. You miss a class, you miss something great. Okay, so see you guys in a few minutes. Stay online. Bye.